Hi everyone, welcome back to Hudson Engineering Academy. We're handling still our lecture series on the topic Moment Area Method. In case you didn't watch the first three videos on this, please watch it so that you can understand and clear the concept. So we are going to solve problem number 3 in lecture number 4, which is find the slope at supports and mid-span deflection, given that the load P at the center, which is this, is 10, length of the total span is 3 meter, area is 50,000 kilonewton meters square, right? Now, the first 2 videos we explained that we have to apply the theorems, the 2 theorems. The first theorems deals with the change in slope equivalent to the area under M by EI diagram. Then the second theorems deals with what? The tangent, okay? The tangent, when you're taking reference, the tangent at a point with reference to another point is equivalent to the area under M by EI diagram times the centroidal distance. Right, those are the 2 theorems. So to solve this question, let's first draw our M by EI diagram and elastic curve. Okay? So this is our elastic curve. This is our elastic curve. And if I extend this tangent, extend that. Okay? So the same if I extend this side. Okay? Yes. I call this rotation at point A and this rotation at point B. Then if this is the original, from this part to this part is tangent at B due to the axis from A. If this is point B and this is point A. Okay? Now, this is also in the same way tangent at A due to line drawn from B. So if this is point C, I will mark this is as C, this part as C1, and this part as C2. This part, and this part. Right? Now, let me draw M by EI diagram. So, this is P. If it is distributed at the support is P by 2, upward forces. So P by 2, this is L by 2, this is L by 2. P by 2 times L by 2, it will give me PL by 4. So this is like this, and this one is also like this. So this is PL by 4. So I need M by EI. Since EI is constant, so this is going to be by 4 EI. This is our M by EI diagram. This is L by 2. This is L by what? By 2. Right? This is our diagrams. So it will help us to solve the problem. First problem, slope at the support. So slope at the support, a simple formula that you should know is that when I want slope at A is going to be this. It's rotating up to this line. This line is maximum up to here. So I will take this TB of what? Of A divided by total length, this span. It will give me slope at A. Same, slope at B is equals to TA of B. So TA of what? Of B divided by what? Total length. Our task is just to find these two now. So this is TB of A is equals to area between B and A. Area between B and A. So this is A, this is B. There are 2 figures. Figure 1, figure 2. Okay? So start with figure 1. This is going to be half times L by 2, which is this, because this I'm dealing with figure 1. Then times this one, which is PL by 4 here. PL by 4 what? Yeah. So now, since it is tangent, I have to multiply with what? Centroidal distance. And this centroidal distance is when I'm standing at the first letter B. This, what is the centroidal? This first figure. If it is somewhere here, from this distance up to here. So I have L by 2, then I have what? This part. This is 1/3 of L by 2. Okay. So 1/3 of L by 2, and then plus L by 2. So that is the centroidal distance from this part plus this part. Okay? I hope that part is clear. Then plus second figure. Second figure is this, which the area still remains the same because nothing has changed. Which is the same as this. I'll just write it. It is PL square out of 16 EI. This same area, this same figure is this same figure. Same area, same area, same area. Multiply with the centroidal distance when I'm standing at point what? B. When I'm at B, the centroid of this is 2/3 of L by what? L by 2. This and this cancel. Simplifying this, therefore, will give us this answer. Okay? So, not to waste time simplify, you can press these fractions from your calculator. You'll get an answer which is PL cube out of 16 EI. Okay? And if the questions wants me to get this slope at A, substitute it here in this formula. So just divide the answer here by L. So PL cube out of 16 EI divided by what? L. Final answer. Our final answer is PL square out of 16 EI. So members, that is the rotation at A. We can do the same to find the rotation at B. Okay. Just erase this. Now, TA of B. If you look at carefully, this is symmetric rotation and a simply supported beam. Rotation at A is just the same as rotation at B. If you write this, you'll find that this expression for TAB will be the same as the same expression for what? TB of A. Okay? So you can prove it. Half of L by 2 times PL by 4 EI. Right? Times centroidal distance of the first figure when you're standing at A. This one. So the centroid is going to be this 2/3 of L by 2. 2/3 of L by 2. This and this will reduce. Plus second figure. Area is PL square by 16 EI. Okay? Times the centroid of second figure from A. L by 2 plus 1/3 of L by 2. L by 2 plus 1/3 of L by 2. You realize that if you simplify this carefully, the answer is going to give you the same as PL cube out of 16 EI. Therefore, rotation at B, okay, is going to give you this, substitute here, divide by L, same PL square out of 16 what? EI. Okay, we have found it, but we did not substitute for these values. We have to do that so that our answer is complete. Rotation at A, same as rotation at B, which is equals to PL squared by 16 EI. So this answer is going to be P is 10 times L is 3 square out of 16 times EI is 50,000. Okay? So press this rotation at A, same as rotation at B. And what is your answer? My answer is 1.125 times 10, 1.125 times 10 raised to power negative 5 in radians. Right? That's our answer. I believe you can take note of that. Let me take you through the second part, that is mid-span what? Deflection. So for mid-span deflection, it's here. It is just this distance from this C to C1. Deflection at C is C to C1 to C1. Okay? So if that is the case, that means how can I get it? It is the total CC2, this minus this C1, C2. It is equals to CC2 minus C1, C2. Okay? How can I find C2? Alright? So C2, if this is a triangle A, O, and this is B, triangle A, O, B, and A, back to A, half of it is what is C2. So that means this is half of this maximum is TB of A, half of it is what? C2. What was our C2 going to be now? This is therefore going to be this value, we obtain it, which was PL cube by what? By 16 AI. We're supposed to divide it by 2. It will therefore give me that value of C2, which is equals to PL cube by 32 AI. Take note of that. Second one, C1, C2. C1, C2. Our C1, C2, if I draw this, because at this point the slope is 0, and extend this is T tangent at C when you're considering the axis drawn from A. So meaning that this is going to be tangent at C, axis drawn from A. It is area between C and A times centroid from C, which is half times L by 2 times PL by 4AI. This is the area. Multiply with the distance. Okay? The distance is coming when you're standing at C. When you're at C here, what's the centroid of this first figure? Okay? It is 1/3 of L by 2. The distance is 1/3 of L by what? By 2. If you simplify this expression carefully, you are going to obtain PL cube out of what? 96 AI. Right? Just confirm that. 16 times 6, 96. Okay? So substitute, don't know that, 2 of them in this expression. If I raise here, I need finally deflection at C is equals to CC2 is PL cube out of 32 AI minus 96, no, PL cube out of 96 AI. Okay? Final answer you're supposed to get from there. So you realize that if the LCM is 96, this is going to be 3 minus 1, it is 2 out of 96. 2 out of 96, when you simplify, it is reduced by 2. So it is PL cube by 96 by 2 is 48. Yeah. This is the deflection at C. This marks the end of our question. So it is problem number 3. Don't forget to watch the previous video. Watch problem number 3. Then you will understand our next problem that we're going to solve, problem number 4. Okay? So please don't forget to like, share, comment, and subscribe to Hudson Engineering Academy so that you don't miss any of our videos, because it is where you'll understand everything in details. Thank you. Bye bye. See you in the next video. Bye.